Hello. Had a sort of a troubleshooting ponder for y'all. We regularly talk about the effects of airflow on being able to check superheat and subcooling on a system. And on that theme, came up with a subject for discussion, and that is profiles. Many of the variable speed systems have ramping profiles for the blowers. And I'm going to cover a few of those in just a moment and show you a few pictures of those to see what I mean. But I want you to imagine with me that you came up on a service call and you were seeing readings like these air side readings here on the left hand side. So let's key in on the dumbed down things, just the basic stuff, okay? And that is, this is the target evaporator temperature. I wish they'd just say your supply temperature target, but that's okay. It's saying the air should be coming out at 57 degrees. And then it says here your actual supply air dry bulb is 48. Do the math, okay? And I believe we're going to come up with something like, I don't know, 8 or 9 degrees. The point is not the exact number, but we're 8 or 9 degrees cold. We can agree on that. Colder than we should be. On the JobLink app, as an example, its threshold for triggering a message about low airflow is 3 degrees. I teach people to pay attention if they see 2 degree supply temperature difference. In other words, it should be 50, it's coming out at 48, that's a 2 degree cooler temperature. So it pops up on our radar to look at a couple other readings to see if we're concerned about low airflow. At 2 is what I teach. But 3 is drop dead. There's something wrong. If you're 3 degrees cold, there's something wrong. Low airflow. So as we look at this, we got 8 or 9 degrees. Can we agree? This thing's way too cold. For some reason, we are not moving enough air on this unit, okay? Right out the gates, we can see that. Let's go down a little further. Right here, the return air wet bulb versus the supply. If I do the math right there, I think we're going to have something like 16.3. There's a range there that I teach folks, and that is from 10 to 12. And the reason I teach that about wet bulb, the 10 to 12 degree difference, is I want people to think about how much latent work is their unit doing so that it helps them understand how we came up with, how the apps come up with what the target evaporator temperature is. You have 3 things. You have enthalpy at the top, and it's made up of sensible heat load and latent heat load. I teach folks to look at the wet bulb and think of the latent with a difference between 10 and 12. That's what they're looking for as a goal on a unit moving 400 CFM per ton. And then on the other side of things will be enthalpy, and we're going to get to that now, and that is a system that is moving 400 CFM per ton, that is metering properly, in other words, the proper superheat from its TXV at the proper subcooling. At 400 CFM per ton, enthalpy will be around 6.7 difference in the stabilized house. And we give a range, 6.7 to 7.6. 7.6 generally means you're moving about 350 CFM per ton. So if we look right here, we can see a difference of 10.2. The max it should be is 7.6. Now, I'm not going to do all the math here and figure it out, but I'm going to guess this is probably somewhere in the neighborhood of about 280 CFM per ton. Can we agree by looking at what I've just talked about here on the dry bulb versus its target and the wet bulb difference? Well, my God, it should be 10 to 12. What do we got? 16. Okay, we have much bigger differences, which is indicating that we're not moving enough air. Now that I've built the case to look at the airside readings, with regards to an eye on the amount of air we're moving, I think we can agree we're not moving enough air. If that's the case, I teach you, don't even waste your time checking the charge. Don't worry about superheat, checking your TXV. Make sure you put the suction line clamp inside when you do it, right? We're not talking about that. I'm not going to talk about superheat or subcooling. I'm too damn cold to begin with. I can't really evaluate the refrigeration process if I'm not moving enough air. Okay, so what does this have to do with the title? And the title is ramping, okay, the profiles of your blower, right? The theme, if you will. We're talking about variable speed motors that have a choice to set the blowers up to have a profile where they don't just come on and run at full speed. The fact is they may start up at one speed and then for another 7.5 minutes go to another low speed and then finally decide to go to your full 400 to 300, whatever you set it up for, 350 CFM per ton. So what I'm going to do is I'm going to bring up some pictures here. I've built the case that we have a unit in front of us that has low airflow. Okay, and what I want to do is show you this picture here. Let's go here. All right, so what you're looking at is out of the installation book for a Trane TEM 6. It's not just Trane we're talking about the theme of ramping profiles. If you come upon a unit and you don't pay attention to those airside readings and you're just looking at superheat and subcooling, you may go down a rabbit hole on making decisions on that superheat and subcooling when you should have been paying attention to the air. So that's number one. Number two, don't respond to low airflow readings without asking yourself, is this a variable speed unit and could it be that it is operating at this moment in time in one of the reduced CFM sections of its profile? So down here, let's blow this up a little bit. Okay, so what we have here is the enhanced mode. I believe this is for Linux. No, TEM 6. Okay, so Trane TEM 6. So we go in here, and if you follow this line at the bottom, okay, the unit is off, and the moment we see this first line, this is when a call for cooling from the thermostat energizes Y. Okay, great. So from here to here, the first 1 minute, you follow this line up and over, it's telling you the blower's going to run at 50% speed for 1 minute. I doubt that you're going to just fire it up and run out there in 30 seconds. You shouldn't be. You should be stabilizing the unit. So I doubt this first minute's really going to catch us looking at the unit going, well, 50% airflow, that's going to show low airflow. You're not going to get out there that quick. You shouldn't, but I doubt you're going to get out there that quick, so I'm not even worried about it. So look at here. From here, come up, come over, and over here and back down. Between these two lines, for the next 7.5 minutes, you're going to run at 80% blower. Most systems in dehumidify mode, just dehumidify mode, lower down 10%. Some of them go 15%. But here, 80%, that's 20% less airflow. So if you're supposed to be between 400 CFM per ton and 350 CFM per ton to check the charge and all that good stuff, right? Well, what do we got here? 20% off of 350, if that's what you set it up for, 350 CFM per ton would be what? 280 CFM per ton. You reckon that's some low airflow in them readings we just looked at? It is. My point is, you cannot check your unit out with low airflow, okay? And if you're on a variable speed, you probably need to take a look at its dip switch setting or its jumper pin setting. It means you got to get familiar with it. And what you would do is go to that unit and you either wait for this unit to get through its first minute, 7.5 more minutes. Maybe you just wait on it. I'm okay with that. Give it 10 minutes. You ought to be doing that anyway, right? And then it should be out of its ramping area where it's at a reduced airflow. Then it's going to ramp up to what? 100%. It's going to go to whatever the full CFM is that it was set for. So from a profile standpoint, you don't have to wait for that first 8.5 minutes in the case of this one to get yourself up to the airflow it was set for. Two notes I have for you. On this unit, 80% airflow. That's what it does in this area of the 7.5 minutes. Well, guess what? If your thermostat is calling for dehum, I believe this one might actually drop 20% more. So it's in this first 7.5 minutes, 80%. If the thermostat calls for dehum, it can drop it another 20% off of that 80. Oh my God, let's see, that was 280 CFM minus 20%. You're running about 230, 240 CFM per ton. You're absolutely flirting with freezing the unit up. In a hot house, maybe not so much, but on cooler fall days, shoulder seasons where it's really not that hot out, if it's cooler inside and you're running the air or you get a dirty air filter, you really are flirting with freezing the unit up is my main point. So dehum lowers the fan even more than this 80% in this example during the first 7.5 minutes. The 100% if necessary. Really, if you know enough about your unit to look at the dip switches real quick and just make sure it's either you wait the 8.5 minutes or you're in a hurry, you could just go up there and defeat this enhanced mode. You just go in the book and it gives you the settings for your pins. If you look right here, none, okay. Right here, switch 5 and switch 6 are off. Okay, you have no delay taking place. The blower's just going to come on and run at 100%. Okay, all right, so whatever you set the nominal airflow to, that's what you're going to get with it in off and off. You could go in there if you're just too impatient to wait the 8.5 minutes, I guess, and defeat it. I think we can wait 8.5 minutes, let it stabilize. Just don't make any decisions on it during that first 8.5 minutes. So this was a really big problem that I see with technicians that get in a hurry on variable speed units. Oh my God, my superheat's super low. If you don't move enough air, you don't move enough heat. You don't move enough heat, you don't put it in the refrigerant, you don't get superheat. So now you wind up going, man, I ain't got but 4 degree superheat. Possibly, right? And that's overfeeding TXP. You can make all kinds of bad decisions with it. If you don't move enough heat, you don't bring enough heat to the outdoor unit to get an idea of how well the outdoor unit's getting rid of it, the level of charge by way of subcooling, if you're not moving enough air. So ramping profiles, you need to be aware of them, is my biggest point. On the CFM, I'm going to touch that real quick. That 100% of what? That's the question. 100% of what? What Bubba and Skeeter set that air handler up before? I cannot tell you how many times I've gone to an air handler and the blower had never been set up to begin with. And you have no idea what it was going to do when you get there. If you don't check it, it only takes a second to get the app out, open it, go to Google Guide, open up the install instructions for a TEM6, and take a look at the dip switch settings. It's too easy. All right, to wrap it up, don't react to the charge on a unit without looking at first the primary performance indicators, my supply dry temperature versus my exiting evaporator temperature, target, check them, no more than 3 degrees colder. My wet bulb, 10 to 12. My enthalpy, 6.7 to 7.6. Check it first. If they are low, don't waste your time on subcooling and superheat. Correct the airflow. Don't rush. Understand if you got a profile, if you go there and click, let me go get my gauges on, and you don't give this thing time to get through its profile, 8.5 minutes in the case of this one, you're going to go down rabbit holes with your brain that you shouldn't waste no energy on. Thought I would share. Over here, we've got a couple of other quick pictures. This on a Lennox, I believe it's a CBX 25 UHV, if I remember right, but right here on these pins, this is where you would pick the different ramping profiles. On the one that probably bugs people the most is this one. Damn, this is confusing to people. And it shouldn't be once you've had someone show you. Someone will show you. See right here, profiles. This is a Goodman variable speed AVPTC, or it doesn't have to be C, which is communicated, just AVPT. And here it's saying profiles, okay? And look up top. Let's see, do we see profiles? That's cooling speed, that's my adjustment. Oh, profile, 5 and 6. It's telling you, based on where it's set, what the profile is. So if you walk up to a unit and you go, let's see, 5 is off, 6 is off. Let's come down here and look for that. Let's see, off, go to the left. Oh, that's speed tap A. Okay, what is A? Here's A. It's not going to have a pre-run. It's not going to have a short run. So it's just going to turn on. In the last 60 seconds after the thermostat gets satisfied, it's going to run the blower. I wish that wasn't there at all, honestly, because when you run the blower after a call for cooling, you re-evaporate some of that moisture and put it in the house, but you're just going to have to live with it. Where we see a problem, profiles, the theme of this video, is when it's set up on D. It's going to run half speed for 30 seconds. It's going to run at 82% for 7.5 minutes. Okay. It will then ramp up to full speed, which is what, 7.5 and 30. That's 8 minutes in. If it had satisfied the thermostat, it'll call the blower to full speed. So you got an 8-minute area where if you get in a hurry, you go checking your pressures, you're going to go ahead and go down a rabbit hole going, what's wrong? Why don't I have no superheat? Okay. We tell folks on installation, set them up on A. If there's a challenge with humidity in the home, we'll have the service techs go in and fine tune and consider the ramping profiles. Might as well hit that. If these air handlers are exterior of the house, I do not recommend having a ramping profile set up. Setting A, full airflow, and shut off. I'm all about that. And the reason is, with low airflow during the 7.5 minute period, that air handler, if it is in an attic, unconditioned space, out in the garage, unconditioned space, can sweat like a pig. Just saying. Doesn't always do it. If the homeowner likes it 80 degrees, they probably ain't going to run that unit long enough to get it that cold. But if you got somebody like 72, 74, as an example, colder temperatures mean longer run times, and that little bit of insulation inside those cabinets during the short run section, right here, 7.5 minutes, can cause water to pool up on these. Okay, so I try to stay away from the ramping profiles if that air handler is exterior, unless a service tech has made the decision because the customer's complaining about humidity issues in the house, for example. This 82% in the case of the Amana and Goodman gets reduced an additional 20%. I believe that's what he told me, was 20%. Hell, I got the message right here. 15%. Goodman drops 15%. So I'm not going to do all the math right now, but damn, that's some low airflow and all the challenges that come from it. So profiles, check and charge while it's in the slow mode, low airflow mode. is a rabbit hole you should avoid. Had one other thought real quick. Units that are in dehum while you have your gauges on. That unit's dropping 10, 15, 20% because it happens to be in dehum while you're gauging up on it. It can have a effect on the superheat for sure, subcooling to some extent. And the point is, if you've got a variable speed unit or even an X13 type system that's been wired up to give some dehumidification, you must make sure to defeat the dehumidification. Whether it's going into a thermostat and turning dehum completely off, that's the simplest thing you could do actually. Then check the system out. Make sure when you check a system out that it does not have dehumidification enabled. Or crank the humidity level, 50, 55 is where it might be. Crank it up to 65, 70 or whatever, nice and high so as to prevent dehumidification, lower CFM, while you're trying to get your readings and evaluate the performance of the air side and of the refrigerant. You can go, man, it's low airflow. Yeah, it might be in dehum. Go to a system. If you see humidity reading out on the thermostat, you better go into the settings and either defeat it, turn it off while you're checking it out, or raise the humidity real high so that it gets rid of it. If you, in either case, whichever one you choose, make absolute sure to return it back to where the customer had it set to begin with. Nothing worse than a free service call to go back and sidetrack you when you got 10 others to do the next day just to turn the humidity control back on. It's 60% humidity in here. Your guy was here yesterday. Make sure you put it back where they had it. Y'all have a great day. Be safe.